Hello Year 10 students, my name is Muskan and I'm here today to talk to you about Newton's three laws and how they apply to aspects of our daily lives. In this video, we will be stating the three laws, stating all the forces present in our chosen scenario and their effects. I will also be going through an interaction diagram and a free body diagram for the chosen scenario. Sir Isaac Newton was born in 1642. Before the age of 30, he formulated the laws of motion and invented calculus. He left us with an amazing discovery which has shaped modern science to this day. Law 1 is the law of inertia. An object will remain in a state of constant motion unless an unbalanced force acts on it. The unbalanced force does not cause motion, it causes change in motion, resulting in movement of direction, speed, or even shape. This law occurs because of a property called inertia. Inertia is the tendency of an object to resist change in motion. This means that in order to overcome inertia in any situation, an unbalanced force must be applied. The second law states that the acceleration of an object is dependent upon two variables, the net force acting upon the object and the mass of the object. The net force is the sum of all the forces acting on an object, and the mass of an object is the amount of matter it contains. And the acceleration of an object is decreased when the mass is increased. Newton's second law can be written mathematically as F equals ma, which is basically the mass of an object multiplied by the acceleration. This will give you the net force of an object. If you want to remember this equation, this triangle will come in handy. From this triangle, we can extract certain equations to find force, mass, or acceleration of objects. These equations are very important to understand when using Newton's second law of motion. The third law of motion is the shortest and easiest. It declares that for every action there is an equal and opposite reaction. What this means is that there is a pair of forces acting on the two interacting objects. The size of the forces on the first object equals the size of the force on the second object, while the direction of the force on the first object is opposite to the direction of the force on the second object. Forces always come in pairs. Normal, frictional, tensional, applied, gravitational, electrical, and magnetic are some of the types of reactive forces. Now that we have a good basic understanding of Newton's three laws of motion, let's take our knowledge and apply it to a random situation. Today's scenario is kicking a ball against a wall. Take a look at this series of pictures. It is pretty simple. According to the first law in this scenario, we can see that the ball accelerates forward when the player kicks it, but the unbalanced force of the wall causes it to bounce back. Arrows show the direction of a force and how big it is. Here we can see that the arrow when the player kicks the ball is shorter than the arrow on the wall. The longer arrow means a larger force. From this, we can conclude that the force from the wall was bigger than the force that the player used to kick the ball, causing it to bounce back. So, the wall causes a change in motion, speed, and direction for the ball. Let's look at this interaction diagram, which will better help us understand all of the interacting objects in our scenario. Each interaction results in a force acting on each of the objects. Here we can see the foot having an interaction with the ball, which then interacts with the wall. The person who kicks the ball and the ball itself has an interaction with the earth. There are many more interactions happening in this scenario, but the main interactions are the ones between the foot, ball, wall, and earth. A type of diagram that can be used to better understand the forces present in this scenario is a free body diagram. From this, we can see that gravity is present. It is pulling the ball down to the earth, but the force of the kick is stronger, causing the ball to go up. Then after hitting the wall, it slowly decelerates towards the earth due to gravity. Now, the second law tells us that the force causes acceleration while mass resists acceleration. In this scenario, if the force when kicking the ball was increased, then the ball will accelerate faster and with more force. This will cause it to bounce off of the wall with more force too. The mass will stay constant if the force is increased. But if the force was decreased, then the ball will accelerate slowly with less force, bouncing off the wall more lightly. Similar to this, if the mass of the ball was increased, more force will be needed to apply for it to move. And if the mass was decreased, less force will be needed to apply. The third law of motion is that for every action there is an equal and opposite reaction. The action in this scenario is the kicking of the ball, and the reaction is the ball accelerating then bouncing off of the wall. Let's say object A is the ball and object B is the wall. When both of these objects interact with each other, they exert forces upon each other, causing an opposite and equal reaction. The size of the force of the ball is equal to the size of the force on the wall, but the direction of the ball is opposite to the direction of the wall's reaction. Overall, from this video, we have covered the 3 laws of motion and how they apply to the scenario of kicking a ball against a wall. I hope you learned something new today and thank you for watching.